So if you've looked at the website, I did add a new card. I'm not certain whether I'm going to get into this section or not, because I still want to make sure that I complete the JavaScript stuff. I know from the kind of interaction we've had in the first lecture that I sense that some people may even be programming JavaScript currently, but I'm not going to assume that. I want to make sure that everybody kind of starts from the same base before we get into the kind of meat of the module, if you like. So I'm going to go back to this section here, and I'm going to go into the slides and pick up the story where I left off 2 weeks ago. I've made some tiny changes to the set of slides, so you may need to download them again after the lecture if you need to. They're very, very small though. So roughly, we covered the kind of objects, which is our structure for representing data in JavaScript, although it's a little bit broader than that, as we'll see in a few seconds. But essentially, anyway, that's the main unit of composition when we're trying to represent complex data in JavaScript. An object is a set of key-value pairs. Keys must be unique, and the values can be anything. Interestingly, the values can be objects themselves. So we have this possibility of nesting objects inside objects, and that's where it kind of gets interesting. So I think where I left off was, actually, it was back here. So here's a prediction, right? This is an error that every single one of you are going to get within this module before the end of the semester. How is that for prediction? And I'm just kind of flagging it now, but you probably have forgotten by the time you get the error, but there you go. And the error is kind of roughly reads, you can't read property of undefined. This error pops up an awful lot with people, and it's quite tricky to debug, but just to explain what the error is first. So I'm saying here that I'm saying when you access a non-existent property of an object, that's actually not, that won't cause your code to crash. What I'm saying is that it's not fatal. Okay, if we try to access, think about it now, you try to access a non-existent property of an object. So generically, you hear, right? So we're going to get a reference to an object, and I try to access this property of that object. That entire expression there is not actually going to cause my program to crash. All that it's going to remain kind of silent is what we say. This expression actually evaluates to undefined. Remember that primitive value that I mentioned 2 weeks ago, the undefined value? So that expression there evaluates to undefined, and as far as the runtime is concerned, it just keeps on executing from there on. So I'm saying that it's not a fatal thing for that to happen in your code. It doesn't make sense, obviously, but that it can arise. However, if you try and do this right, if you try to access a property of something that is not an object, then that will cause your runtime to crash. I'm saying you've accessed a property of a non-object. A non-object, I suppose, essentially is a primitive, really. Now, so if I have a variable that's pointing at a primitive, and I try to access a property of that, clearly that expression just doesn't make any sense. And it will, when the runtime tries to evaluate that, it will actually throw an exception, and your application will crash. Now, of course, undefined is a primitive value. So if you find yourself trying to access a property of the undefined value, equally, that will cause your application to crash. So in other words, if I tag down property y up here, if I did dot property y, that entire expression now will actually cause my runtime to throw an exception, and hence, well, whenever an application throws an exception, it actually crashes or it's fatal. And you get something like this, some variation of this in the console, really, in the browser's console. I am talking about running code inside the browser now, but equally this can happen if you're running JavaScript via the node command line tool. And I suppose I don't really need to expand it any further, but I have one example of it in the list of examples that I've given you, which I think is this one. Yeah, so here's our me object we had from 2 weeks ago. And if I do a, sorry, is that the example? I beg your pardon. Is that the example I want to look at? No, it's not. It's this one. Okay, here's my me object. And if I do I'm just using console.log just to prove this. If I do a console.log of me.finance.deposit, and you can see finance here doesn't have an internal property called deposit. So this console.log is just going to console.log the undefined value. In the next line, then I am ignoring that, okay, and I'm doing a .deposit.bank. Now, because me.finance.deposit, because that evaluates undefined, when I then try and kind of index into that, if you like, that now is going to cause, it's going to throw an exception, and the runtime will crash. And okay, I mean, I don't really need to prove it to you. I'm sure you take my word for it, but if I just enable this and do my go live, then there you go. Yeah. So again, just remember that is going to arise with you. It won't be as obvious as the example I'm showing you there, but it will definitely occur because, and if I flip these around, I don't want to dwell on it too much, but if I flip these around, no, the undefined never happens at all. In other words, like the second line there never gets executed. This never gets executed at all. If I flip them back again, and save. Like the first line is executing, that console.log is happening, but then it crashes because it hits that that type error, as it's called. Okay. So just remember what I predicted there. Arrays, obviously JavaScript has arrays. They're just like arrays in any other language, really. The way you represent them is usual, a square bracket or the subscript kind of notation for enclosing your literal array, and you separate your array entries with the comma. Arrays are not typed as they are in some languages. What I mean by that is the array can have a mixture of types in it. It could have primitives and objects, and it could have inner arrays, etc., etc. Probably not a great reflection of your design if you have an array with a mixture of different data types in it, but as far as the runtime is concerned, it doesn't complain about that. That's what I'm saying here. The values can be of mixed type. And we use the subscript notation, as we do in all other languages, to reference a particular element within the array, where the subscript starts at 0, as it does with all other languages. Don't think I'm going to look at the sample in the folder. You can look at that yourselves. It's fairly predictable kind of stuff. An interesting fact, which is something that you can know but discard, internally actually JavaScript doesn't have arrays as natively, as we say. Most of the languages have arrays built into the language natively. JavaScript actually doesn't. Internally, actually, arrays are stored internally as objects, where the keys are the values 0, 1, 2, 3, 4, 5. That's how it happens behind the scenes. But, you know, as I said, that doesn't really help you in any way or shouldn't hinder you in any way, but that's actually what's happening. So the only really data structure that is built in natively to the language is the object structure. That's it. So it's very simple in that sense, but obviously it would need to support arrays. And of course, the difference between an array and an object is an array is an ordered list of elements, whereas an object is not an ordered list of elements. There's no sense of the first property in an object and the second property. We don't talk about them in those terms. They're not ordered. Also, so in a sense, an array is a special type of object. And the other way it's actually special is it has a number of additional properties that ordinary objects don't have. And that's what I'm talking about here. So you can refer to the length property of an array to get the number of elements in it. It has some utility methods for adding elements to the head and tail of the array. So push and pop are two methods that allow us to manipulate the tail of the array. That's the end of it. So if we want to add an element to the end of the array, we use the push method. And there's an example of that in the code that I provide you with. And we use the pop method to remove an element from the tail of the array. And the shift and unshift methods do the same thing to the head of the array. And there are some other methods as well, like join, etc., etc. So with arrays and objects, that's all you need really to represent any type of data structure that you could possibly come across in any problem domain. And so I'm just giving you sort of examples here of what you can construct. So let's suppose we have an array where the elements are actually also arrays, if you can visualize that, okay? And so an expression like this makes sense in that context. So array outer is our reference to the outer array. Subscript 3 refers to the fourth element. So the expression array underscore outer subscript 3, that entire expression is going to evaluate to another array that's internal. And so subscripting into that array would make sense. So again, you need to be able to understand that expression there and rationalize it. If we had another example where we have an array of objects, again, you need to visualize that in your head. So an expression like this would make sense. The array name, I'm subscripting into it. So that entire expression evaluates to an object. And so adding on dot, some property onto that makes sense. And I have another example down here. So this ability to understand and write this kind of code should come easy to you, hopefully, as we get into doing some actual coding ourselves and being able to interpret them and being able to write it ourselves. I'm going to pause for a second if there are any questions.
No.
Great. String templating was something that was introduced in ES6. You might remember the very first little program that we looked at. We had this ugly kind of expression here where we kind of concatenated a bunch of values using plus operator and empty strings, and you know, that's fine, but it's very error prone if you had to do that all the time, if you want to construct strings by using this concatenation operation all the time. So because of that, and also because of what was possible in other languages, the ECMA group introduced what are called string templating. And so string templating is where we've got something like this, where we define an entire string from beginning to end. Now, be careful. This is not the single quote here. This is the back quote. Okay, if I put single quotes here, then this whole string templating doesn't work. So this entire, what happens at runtime with this string template, is what we would call this, is the runtime will actually, when it finds dollar curly brace, close curly brace, it evaluates what's inside the curly brace. And the result of that evaluation is included in the overall string. So in this case, it's evaluating foo1, foo2, foo3, and foo4. Now, admittedly, that's quite long-winded as well in terms of a syntax point of view, but that's just one illustration of it. Turns out now that you can have anything you want to inside the curly brace. So you could actually have a function invocation here, where in that case, it's whatever the result of the function, whatever the function returns. I haven't talked about functions, I just realized, but you can have any kind of expression in here anyway. You could have an arithmetic expression, and the arithmetic expression will be evaluated, and then the result will be inserted into the overall string. So at runtime, it evaluates whatever expression is between the opening closing curly brace. That's string templating, and there are some examples of that in the code that I've given you. So this idea of evaluating what's within the curly braces is what's called interpolation. You can have multi-line strings as well. If I just quickly flip over maybe to string templating. Anything interesting? So we've got a couple of primitives, and you can see here I've got a little function here where I give it a height in the old measurements in feet, and it converts it to meters. Yeah? I know we haven't seen functions now, but you can kind of work out what's happening here. It's a method, if you like, or a function which does some sort of computation. Now, in my string, I'm actually, here's my string template here that I'm constructing, and I'm assigning the string template to a variable, which is fine. But inside in one of the parts of the template, I'm actually calling the function that I have in the previous line there. So that's that highlights that point that anything really can be within the curly braces of your template. Multi-line strings are supported as well, and I have an example of that here. Okay, and again, the multi-line string begins with a backtick and ends with a backtick. And you can have any number of interpolations going on inside that multi-line string. We don't really care about, we will use string templating in this form up here. Multi-line strings won't really arise as such, but that's string templating. Right, that's all I want to cover on the kind of data representation side of JavaScript. The other side of JavaScript and the other side of any language is how do you represent behavior or logic? And just like there's only one unit of composition on the data side, that being objects, there's only one unit of composition available to us in the functional or in the behavioral side as well, and that is something called functions. So functions are the unit of composition for logic in JavaScript. And again, there's the pre-ES6 and post-ES6 kind of periods of the language. So from ES5, in other words, from the beginning of the language, we always had something called function declarations. We also had something called function expressions. And I appreciate some of you may have already seen this now and worked your way through the associated lab, but I'm going to set my way through it anyway, if that's okay. We have function declarations and function expressions, slight differences between them. It actually arose, this topic of hoisting arose in a discussion that we had in the lab 2 weeks ago. This idea that you could declare a function within your within a file, let's say, and you could invoke that function prior to its declaration, which was kind of an odd thing when you looked at the source code. But the reason that was possible was because at runtime, the function declarations are moved to the top of the file, if you like. I'm not sure why Brendan and I actually had that feature in the language. It was quite unique. But as I said in the lab, in the exchange on Slack, that feature is kind of being deprecated. as much as possible, but it's there anyway, and you may come across it when you're reading about the language. I'll show you an example of the difference between function declaration and function expressions in a second. Then in ES6, we still have function declarations and function expressions, and indeed when you read modern, if I might call it, JavaScript code, you'll still see this style being used, so that there's a mixture of them. But as well, ES6 introduced what are called arrow functions, and an arrow function is really a cleaner form of function declarations stroke function expressions. Really, function expressions, it's a cleaner form of function expressions. By clean, I mean there's just less syntax. We often talk about languages being quite noisy or fussy. When we talk about that, we're saying that there's a lot of syntax in the language which seems a little bit heavy. Arrow functions try to quieten down the language, mainly again because when you look at some other modern languages, they're not as fussy in terms of syntax. So arrow functions was an attempt to eliminate as much as possible of the syntax associated with function expressions in particular. And there's even a shorthand form of arrow functions, which initially is quite off-putting when you're trying to read it, but you get into it after a while. You get into understanding the syntax. Now, as well, from day one, JavaScript has had something called anonymous functions. Clearly, functions have to have a name. If a function doesn't have a name, how do you call it? How do you invoke it? But anonymous functions are functions that don't have a name, which may seem like a useless kind of feature, but in fact, it's something that we use an awful lot, and it's something that you're going to see an awful lot. But an anonymous function is a function that doesn't have a name, in very simple terms. You can code it as an arrow function or as a function declaration, as we'll see. So let's look at some of the samples. So this is a different folder now, and it comes with the second lab. Same kind of structure to this thing. I've got a number of files, and then I've got an index.html that we can kind of enable and disable the files one by one and see what's happening in the browser. You may wonder, if you're familiar with Node, you may wonder, why do you not just run the files using Node from the command line? And I could have done that, of course, but because the first half of this module is very much focused on the browser and what's happening in the browser, that's why I chose to illustrate JavaScript in this way. Okay, so usual story, the only one that's enabled is 0.1 functions, and I'm going to kick off my live reloader. Just kill that. And we don't really care about what's happening in terms of the UI. We're really only interested in the browser's console. Okay, so I've got an object here. I've got the me object, and I've got the her object, and I've also got the here object. Okay, and so the idea is that the first two are meant to represent people, and the third one clearly isn't. So I said function declarations. Here's an example of a function declaration. This is the syntax for it. So the keyword function, the name of the function, followed by the parameters, and then you enclose the body of the function in curly braces. And function doesn't do a lot in this case, but it's fine. What it's meant to do is it's taking one parameter. Now remember, JavaScript is not a typed language, so there's no way of guaranteeing from a kind of coding point of view that the object that's being passed in is the right type of object. Okay, that's just a general point. So the idea of this little function I decided was I was going to have a function that checked to see whether the object that was passed into it represented a person or not. And I just decided a person is somebody that has a name property and has a gender property. Is that what I'm doing? Yeah. Okay, that's my rationale. So clearly here would not satisfy those criteria because it doesn't have a gender property, although it does have a name. You might remember from last day, this is one way of checking whether an object has a property or not, the in operator. Another way of actually writing it is by saying, if you go person dot name, triple equals undefined, you'll see that used quite a lot actually. That's another way of checking to see whether an object has a property or not. So if I add on person dot name equals undefined, if that evaluates to true, then we know that the object doesn't have the name property. I didn't code it that way. In this case, I just did it that way. So that's function declaration. Function expression is where you actually assign the function to a variable, which is what's going on here. Okay, I'm not giving the function a name here. The name is actually the name I'm assigning, the name of the variable that I'm using. So this idea of assigning a function to a variable is kind of unusual if you come from a very classic object-oriented kind of background. Although if in terms of Java, you have this notion of lambdas now, and this is essentially what is my function is here. It's a lambda. So JavaScript had this notion of lambdas long before, JavaScript had this notion of lambdas long before Java actually had them. But it's from a technical point of view, we would say that this is a function expression that's going on here. But essentially, again, we're just declaring a function that does something. This function looks like it checks to see whether the object that is passed into it, which hopefully is a person object, has a middle name or not. It does more than that. It first of all checks to see whether the object is a person using my method above, and this is how you throw exceptions. So I'm just throwing little bits of code at you as I'm working my way through this now. We know what exceptions are down here, and then I'm just checking to see, does the person already have a middle name? If they do, then concatenate the second middle name. There's two parameters being passed here, the middle name and the actual person object. And all I'm doing here is check to see whether they already have a middle name. If they do, then I extend it. If they don't, then I add middle name property onto the actual person object. And I couldn't think of anything sensible to return, so I'm just returning true if nothing unusual happens. Hopefully you appreciate that. See, this expression here is checking to see, does the person already have, actually I was just mentioning that while ago there. See here, this expression here, this is another way of checking to see whether an object has a particular property or not. Person.name.middle triple equals undefined. If that entire expression evaluates to true, that is telling me that the name object there does not have a property called middle. So if we go back up to our objects, here there's no middle name, whereas this person does currently have a middle name. Okay, and so if that expression evaluates to true, then the net effect of this line here, the net effect of this line here is to actually add a new property called middle to name. And here I'm just invoking that function. I have to wrap it in, well, I should wrap it in a try catch block because of course the method could throw an exception. And that try catch block, I'm assuming people are kind of familiar with this kind of try catch block idea from other languages. As I said, I'm not assuming people know JavaScript, but I am assuming people are familiar with other languages. So some of the features of other languages are reappearing here, and I don't need to explain them, hopefully. But by all means, ask questions if you want to. I'm just going to pause for a second if there is a question.
No.
No? Okay. Arrow functions. Remember I said arrow functions are essentially a cleaner syntax for the kind of functions that we've already seen up at the top of the file, and in particular function expressions. So here is another, essentially it's a function expression, but I'm using the arrow function syntax. So the keyword function no longer appears. And so the way you interpret this is you look for the arrows symbol, and what's to the left of the arrow are the parameters of the function, and what's to the right of the arrow is the function body. Again, the function body has to be enclosed in curly braces. That's our block, if you like. And that's it really. So this is an arrow function. Well, sorry, it's just a function using the arrow syntax. And it just works as before. So I'm declaring a new function called salute. And again, I'm kind of checking what I'm doing in the body of the function probably isn't too interesting. And you can work that out. But again, what I'm doing is I'm checking to make sure that the thing that's passed into me, person, is actually a valid person object. And if they are, then what am I doing? I'm trying to determine what gender they are, and based on what gender they are, I'm returning either a string that contains Mr. or Miss in the title. Just in passing, if you look at this line here, I'm showing you an example of something called a ternary operator. Again, the ternary operator is something that you see in all other languages, so that's why I'm just introducing these things kind of randomly, really, because I'm hoping that people are able to interpret it because they have seen it in other languages. But just to be sure, the way the ternary operator works, there's two parts to the ternary operator. There's this question mark part and the colon. So the way it works is I'm declaring a variable here, and what happens at runtime is this expression here is evaluated. Okay, you can see it's an expression that's going to evaluate to true or false. And if that expression evaluates to true, then the thing after the question mark is assigned to the variable. Otherwise, the thing after the colon is assigned to the variable. So it's essentially a shorthand form of an if-else statement. Again, you will see me using that ternary operator a couple of times in my code. Any questions? No? Okay. Now, the shorthand form of the arrow function is a bit off-putting initially. It won't be off-putting when I show you small little snippets of it here, but when you see it used in larger volumes of code, it can take a little bit of time to interpret it, I suppose, as you read through the code. But what's different in the shorthand form of the arrow function versus the normal arrow function is that a lot of the syntax is actually removed. So what do I mean by that? I've got an arrow function here again, but, and okay, there's my arrow, and I've got my parameters to the left enclosed in parentheses. To the right, it looks like I don't have a body, because my body, I said, if we compare it to the arrow function up, if we compare it to the arrow function here, I said the body should be enclosed in curly braces, but I don't have any curly braces in the example. Sorry now. Oh yeah, I don't have any curly braces here. And it turns out if the body of your arrow function consists of one expression, and that expression is the return value of that arrow function, then you don't need the curly braces. That's number one. Rule number two, you don't actually need to use the return keyword in that case either. So if I was to write this the long-handed way, this is what I would need to do. Put in my block. Move that in and stick in the keyword return. Okay, that now is the exact same as what I had before I made those edit changes. So we're just saving a little bit of syntax, not a whole lot, I guess, but we are anyway.
I think you can omit the parentheses on line 77, you know, if you want.
Pardon? Oh yes, yeah, you're correct. Yeah, there's another part of the syntax that we don't really need, which is the parentheses. That only applies if there is only one parameter. If there's more than one, then you do need the parentheses. And in fact, if there are no parameters, you need the parentheses as well. Okay, so if there were no parameters, I would still have to do that. Otherwise, it can't actually kind of break down the code for you or interpret the code for you.
Dermot, this is just to save on writing code. It doesn't change the functionality, no?
No, and I think what you probably should do initially is write it the long-handed way. It does take a little bit of while to get into the habit of representing it using the shorthand arrow function. At least I find that anyway. And in fact, if you never write, if all of the, you certainly will have a need to write arrow functions in the code that you develop. But if you never use a shorthand form, I mean, we're not going to be checking for these kind of things. But it's just a convenience for the programmer, really. Although, you know, some of the code that I will give you, you will see the shorthand form of the arrow function. And so it's kind of important that you develop the ability to interpret it and break it down for yourselves.
Okay. Can I just ask you another question before you move on? In the ternary operator, you have two choices there. Could you have a number, or could you have more choices than Mr. and Miss?
No.
You could just have two.
It's a classic kind of if-else, and that's it.
I understand, yeah.
Yeah.
Okay.
That's good. Okay, so that's arrow functions and shorthand arrow functions. And, you know, when you see it in a simple little example like that, you know, there's no big deal, you would think. But it's when you start embedding it in larger volumes of code, it can become problematic in terms of understanding the code. The last thing is anonymous functions. Anonymous functions are functions with no name. And so there's a bit of chicken and egg going on here now, but the simplest example that I could show you of where anonymous functions come up is in something called the array for each. So let me just explain this code kind of line by line. So, okay, I've got an array here. That's straightforward enough. And here I'm referring to an array and I'm invoking a method called for each. What the for each method does is it iterates over the array one element at a time. And for each element in the array, it will call the function that you pass to the for each. The function in this case is this guy. Okay, so here I've got an anonymous function. It's a function that doesn't have a name. What it does isn't too interesting. But just to be specific about it, the for each method expects an anonymous function, and what the for each method will do is it will call that function once for each element in the array, and for each invocation of that anonymous function, it will pass into it a reference to the element itself, which is going to be the first argument. It will pass in the index position of that element, and thirdly, it will pass in the entire array. Array here is actually going to refer to the entire array. Should the anonymous function need to actually use it. And all I'm doing is a console.log or some stuff. Again, not too interesting. So that's an anonymous function. I could have used function declaration for my anonymous function. I'm using the arrow style here, but I didn't have to. Anonymous functions have been part of JavaScript from day one, and a very important part of JavaScript, as it turns out. So it doesn't really matter what style I use for my anonymous function. In fact, I could have taken this code here and assigned it to a variable up here, and then just use the variable name in my for each method call. Another example here, here's my shorthand, and as one of you mentioned, I don't really need this guy. Just go back to this example here. I said there's 3 arguments. In fact, the only argument that's mandatory is the first one. The other 2 are optional. And I only included them because I'm actually using them here. But if I wasn't using array or index in the body of the anonymous function, then I can just, I can just get rid of them here and here. Okay, so JavaScript has this idea of variable argument lists associated with functions, but it wouldn't work in this case because I do actually use them. Down to this example here, and really, again, it's for each I'm using just for simplicity's sake, but my anonymous function is again an arrow function, and because the body of the arrow function only consists of one statement, I can actually use the shorthand form of the arrow function. So there's no curly braces wrapping the body. There's no keyword return, etc. There's no return up here either. Sometimes anonymous functions or any type of function really may not return anything that's useful. So you don't have to have a return statement. We don't here, as it turns out, but yeah. Okay. What's next? Kind of cover those points, right? That the arrow function is lots of the syntax in the arrow function is optional depending on the characteristics of the arrow function itself. I've gone over that already. If you're a little bit uncomfortable with arrow functions, what you can use is, well, if you're uncomfortable with arrow functions, but you're familiar with kind of old JavaScript, if you like, and you could convert your arrow function, be it shorthand form or otherwise, into the old syntax to help you to understand it. That's all I'm showing you here. There is this browser-based tool called babel.io. It's this website here, babeljs.io, sorry. And it has a nice kind of little feature built into the website, which essentially what you can do is you can paste in your modern JavaScript here, and it will generate the equivalent ES5 JavaScript over here. So you just do a cut and paste. And that's really what I'm showing you in that PowerPoint slide here. I've done that. I've taken 2 of the arrow functions that I was just talking my way through there. I pasted them in, and it shows me what the equivalent is in ES5 syntax. Again, that would only be meaningful for people, or useful for people that are familiar with ES5 JavaScript. If you're kind of new to JavaScript, then there's no point in kind of referring back to ES5 syntax. It doesn't really help you, I don't think.
There is also the opposite. There is one website called Lebab, which is doing the opposite. And actually, it's quite helpful. Yeah. If you wanna convert, old pieces of code, into ES6. Yeah.
Yeah. You might.
It's called Lebab.
Sure. Yeah. You might put a message on Slack actually about that. I haven't come across that.
Yeah.
Great. This is just some nice facts to know, but won't necessarily impact on us. So from the outset, JavaScript had this notion of constructor functions. We won't need to use them, but you know what constructors are from, let's say, classic object-oriented languages like Java. A constructor is a method that creates an instance of an object. Well, constructor functions actually serve the exact same purpose in JavaScript, and they have been part of the language from the outset. Now, I'm not going to cover them. A constructor function is declared like any other function-ish. The way you actually invoke it is slightly different from how you would invoke a function ordinarily, though. And its purpose, the purpose of a constructor function is to create an instance of an object. So I might have a constructor function that would create instances of person objects. I had persons there in my samples. And really, classes were introduced to JavaScript in ES6, but when you transpile JavaScript classes back to ES5, what you would see is that it's actually using these things called constructor functions, which, as I said, have been part of the language from the outset. That's just an interesting fact to know, but we won't ever need to use them, because not only will we not be using classes, we won't be using constructor functions either in any of the code that we write, as it turns out. Side effects is the next thing I'm mentioning here. It's just something that's not specific to JavaScript now, but when we talk about the side effects of a function or a method, by the way, a function and a method are essentially kind of the same thing in terms of what their role is. Their role is to encapsulate a body of logic inside a unit, whether the unit be a function or a method. But a function or method that has side effects is when it changes the value of some variable or data structure that's outside of its scope, or that's not local to it. Okay, so a function or method that has side effects is one that changes the value of a variable or data structure outside of its own scope, that is not local to it. Equally, and the two examples from the sample code that I'm showing you, the add middle name, that does cause side effects if you think about it, and you go back and look at the actual code itself, because it changed the structure of the person object that was being passed into it. The salute method did not have any side effects. So we would say that the salute method is a pure function. I'll come on to pure in a second. By side effects now, we're actually including if a function performs I/O, then that is classified as a side effect. It's doing things outside of its scope. Pure functions or pure methods are methods that have no side effects. And ideally, we'd like to write as many functions as possible that are pure functions. Why is because it actually makes it a lot easier to rationalize and debug your code if you can achieve that. And there is a whole kind of category of programming called functional programming, where you essentially, every function that within your application is a one that is pure, i.e. it does not have side effects. So it's a very interesting topic within programming, functional programming. And every now and again, that will arise in our discussion on React. A lot of the functions are pure functions or have no side effects, and some of them do have side effects, can't be avoided. So they're just some facts and bits of knowledge that I've just scattered across there. Now let's move on to something called higher order functions, which is something that is very important and something that we see an awful lot in our code, both in the React side and in the second half of the module on the Node side. So my definition there of a higher order function is a function that takes another function as a parameter. We've seen one example of it already, actually. The ForEach method took a function as a parameter. We essentially passed a piece of logic into our method, and it used that internally. So the ForEach actually invoked the anonymous function that we passed into it. So we would say that the ForEach method is an example of a higher order function, stroke method. Some methods and functions actually can return a function as a response. We will come across one or two examples of that. It's quite difficult to design your application around this idea of higher order functions. We won't necessarily be doing that, but we will see lots of examples of higher order functions. And again, it's very much being comfortable with the syntax when you see it being used, because we have kind of functions inside functions, and you can get lost in the syntax, and it can be difficult to interpret initially. So from a kind of pure literal syntax point of view, I'm using a function declaration here as an example. So I'm declaring some function, and one of the parameters to it is another function. The parameter that is a function we tend to refer to as a callback. So a callback is a function that we pass into another function. It might have other parameters as well of primitive types or object types, but at least one is a callback. So we would say that this overall function here is an example of a higher order function. And the reason I'm covering this, and I'm going to do a little bit on it, is because, as I said, we see an awful lot of this kind of coding style, both in the React side and the Node side. And so to try and narrow it down to something that's kind of tangible, what I decided to do was to take the array data structure type. It has a number of methods built into the language, all of which have this higher order function characteristic. And we've seen one already, the ForEach method is a higher order function, and there are 3 others that we'll just skip through. So I'm conscious of the fact that we've kind of seen an example now, and I've explained it. So again, if we take the ForEach example, we've got an array. Here we're calling the ForEach method on the array, and ForEach in this case only takes one argument, which, as we know now, is a function. And again, I'm using the anonymous function style here. And in fact, I'm using the function declaration of an anonymous function. And I've already explained how this works. But in terms of higher order function, what we would say is that ForEach is an example of a higher order function. Now, the other ones, the map, reduce, and filter. To give examples of those, I suppose you could say I've complicated it a little bit, but what I've done is I need to explain the context now for the samples that we're just going to step through. The context is there is this web API or web server, if you like, called the random user web server. And if you send it a HTTP request, something like this, so it's randomuser.me. In fact, I think I've brought it up in the browser. This is the kind of website associated with it, but it's not a website, it's actually a web API. And if you send it a GET request with this kind of URL, then what it will return is an array of randomly generated user profiles. And so we're going to use that array of profiles to discuss the array map and array filter and array reduce higher order functions for ourselves. Okay, so that's the random user web API. This is the architecture of the little examples that we're going to step our way through, and it's quite a complicated architecture, as it turns out. So I'm going to be running a web server, and it's going to be my live server, which we've seen 2 weeks ago. The live server is going to be serving HTML and JavaScript to my browser. The HTML actually is not interesting. The JavaScript is. It's going to be sending JavaScript and HTML down to my browser. The JavaScript code, when it executes, is going to send a HTTP GET request to the random user web API. It's going to return an array of objects, and it's an array of user profiles is what I'm calling them. And then in the JavaScript code, I take that array of user profile objects and I just process them, and I do some output to the browser's own console. I don't do any output to the actual browser screen itself. That would be unnecessarily complicating the whole thing, which I don't want to do. Just by the way, it's something that you'll come across later on with Frank, I think. There is an app. You can also get in the form of a plugin to Chrome called Postman. It's a nice kind of tool really for playing around with web APIs. So my web API in this case is the random user generator web API. And what Postman allows you to do is to send requests to a web API, and you can kind of interrogate the response that it sends back to you. And this is what the screenshot is showing. You can download the app yourselves later on if you want to yourselves. But essentially, when you download the app and get it up and running, what you can do is you can put in the URL that you want to send the HTTP request to. You can select what type of request, get, put, post, or delete. Then you click your send button over here. And down here, then you can actually see the body of the response that comes back to you. So it's quite useful if you're working with a web API and you're not familiar with the structure of the data that it returns back to you. Because remember, a web API is just all about returning data back to you. If you want to find out about the structure of the data that it returns back to you, then Postman allows you to do that, because you can now look at the response data that comes back here to find out what is the structure of that data, and in particular the structure of the objects within the response. That's really all I'm showing you here in that screenshot. Right, so let's look at, just checking my time here, sorry. Let's step through some of these examples. Okay. The other reason I'm kind of arguably complicating it is because it will serve us well when we get into the React stuff. So here's web API call.js, and this is the file that is being currently executed by my index.html. Sorry, now I just want to clean this stuff up here. Oh, okay, I haven't saved it. Right, so my index.html has activated 02, and here is 02. Now, there is a function built into all modern browsers called the fetch function, and the fetch function allows us to send a HTTP request to a web server, make that kind of a call from a web server. So it looks like what I'm doing here is I'm sending a HTTP request to my random user web API, and I'm telling you that what I'm actually asking it for here is I'm asking it to return 6 user profiles to me. Now, of course, this is what we would call an asynchronous method. What I mean by that is the fetch method does not return back the result immediately. The result comes back sometime in the future. Hence, it is an asynchronous call because it's making the request across a network. So the way I want you to understand this code is eventually the response will come back. And when the response does come back, the next thing that happens is the browser is going to call this method called then. The then method takes a function as an argument. It calls that function and it passes into that anonymous function essentially what has been returned by the web API. So response here is going to contain what was returned by the web API. Now, in general, the response that comes back from the web API may be fragmented, and it needs to be reassembled back at the from the requester's side. So what is actually going on here is I am reassembling the fragmented response that came back from the web API. That's what the response.json method is doing. Okay, that wouldn't be obvious now at all, you might think, but the comment over here is telling you that the fetch method assumes that it is a stream that is being returned back by the server that you're interacting with, the random user server, and you need to reassemble that stream. So that's what I'm doing here. Eventually, the stream that's returned back by the random user web API is finished. And when it is finished, it is only then that this then method is invoked. This then method is also passed an anonymous function. And it calls that anonymous function, and what it passes into it, which I'm calling response body there. Response body is going to have the full HTTP response body that was returned by the random user web API, which effectively will contain our array of user profiles, but it will contain other stuff as well. And so what I'm doing here is I'm picking out a particular key in the response body called the results key. Now, the reason I know that there is a key called the results key is because I used Postman to help me work out what is the structure of the response that comes back from the random user. And when I did that, I found that in the body of the response to come back, there is in the object that was returned by the random user web API, there was a key called results. And that results key, the value associated with it was my array of user profiles. Do ye get that? Is that okay?
Yeah,
now,
it is.
Yeah.
Can I? So is this the way to do it now? Because I've seen Ajax calls before. Obviously, that's quite old now. jQuery was doing stuff like that.
Yeah.
And now you get promises as well, which I don't quite understand. And then each of these sort of frameworks does it in a different way. So this seems to be built in to the browser. What is the best way for us to do it?
So you mentioned promises there. This is using promises. This is the promise-based approach. The original approach, we could always make Ajax calls, as you call them. We could always call a web server from within our browser. The very first way we used to code it was using what are called callbacks, nested callbacks. So we had function calls within function calls within function calls, and it was extremely difficult code to interpret, to read, really, sorry. It was very difficult code to read, and we had this thing called callback hell, which you may have heard of. To try and overcome the callback hell problem, the ECMA people introduced this promises style of programming, and that's what you're seeing here. Now, there is yet another style called the async await style of programming, which arguably is less noisy from a syntax point of view than what I'm showing you. So I'm showing you the promise-based approach. What is the best approach? Well, I'll tell you that the most modern approach is using something called the async await pattern. And I think Frank will actually cover that. And he also covers promises. Admittedly, now I've certainly dived into this asynchronous coding here all of a sudden. I am explaining it at a very kind of high level without explaining the technical side of it, although I'm happy to get into the technical side of it. But what I'd like you to take from just this lecture, I suppose, even though it's not a nice thing to say, I'd like you just to treat this as boilerplate. Okay, and all that's going to change in this boilerplate, no matter what web API you're going to call, all that is going to change is from here down. You're always going to be doing this. Okay, the actual URL is going to change. You're always going to have this stuff here where you regard the response that's coming back from the web API as being a stream or a fragmented response that has to be reassembled. So this is just boilerplate that will do that for you. And this kind of, what we also have here is a programming style called method chaining, because the then method is being invoked on whatever fetch returns. Because here I've got the dot then, like I could put that. Okay, I'm calling then on whatever fetch returns. That's not a JavaScript thing. That is a programming style called method chaining. You'll see it in other languages. What I did actually, I'm not too sure if it's going to help really, but probably not the way I do things, but I've actually rewritten the whole thing in a kind of a long-handed way. This is the exact same thing now, right? So here we are, we're calling the fetch method and we're assigning what it returns to a variable. And in the next line, I'm calling then on that variable. And whatever that returns, I'm assigning it to another variable. And here we go again. I call then on that variable as well. And then we are processing the actual data. Here we're actually processing the data that comes back. Why we don't do it this way and we do it the previous way is because we don't actually use that variable there, nor this variable. We don't use them anywhere else. So there isn't really any benefit to assigning the then return value to a variable if you don't use it anywhere else. You can still do it this way. But if you're not using the variable, then why not just chain them as I did on the other file. Anything else I wonder? I'm not surprised now that this is a little bit not obvious in terms of understanding it, but hopefully you can accept what I say there when I say just treat this as boilerplate from here up. You can essentially cut and paste that and just change the URL to whatever web API you're talking to. And what's going to be different is how you code from here down. And what you code from here down will require you to understand what is the structure of the response that came back from the web API. Every web API will not return an object that has a key called results. Okay, so that won't work every time. Also, to try and prove to you that there is something unusual going on here, I have a console.log here at the very bottom. Okay, now you might expect, if you didn't realize that this was not asynchronous, if all of this code up here was not asynchronous, you might expect that the first thing would happen is this line of code would execute, then all of this would execute. In other words, this console.log stuff would output to the screen. And eventually, at the very end, this console.log would execute. But if we look at the browser, you can see that the console.log that I have at the very end of the file, it actually outputs first. Why is that? That is because all of this code up here is asynchronous. And again, I'm kind of using that term kind of blandly, but what it means kind of is that none of this is going to execute until the response comes back from the web API and it has been reassembled. This part won't execute until we get the first part of the stream back from the web API. This code is not going to execute until all of the fragments of the stream has been reassembled in the browser and we're ready to process the entire data. It will not execute. Now, the browser is not going to wait for these things to happen. It's going to continue on executing the rest of the code in the file. It does not block the thread, in other words. So that's why the very console.log that we have here at the very end of the file, that's why that gets executed first. And eventually, you know, the data comes back and it's reassembled, and eventually kind of this stuff gets executed. So the browser takes care of managing all of that for you. Well, it's really the API, the fetch, and the whole promises kind of model takes care of that for you. And so I don't want to dwell on it any longer now, because it won't necessarily make it any clearer for you if I keep on talking about it now. You will need to go back and kind of reflect on this, I think. But again, at the risk of boring you with repetition, try for now and just regard this as boilerplate, and you kind of pick up the story read from here. This is where the real processing of the data is going on, and what you do inside here is really up to you, depending on what the object of the program is. Any other questions? I'm happy to discuss this for the rest of the lecture. I have no problem with that, because it is going to be very important. Everything that we do in React is going to involve talking to a remote server. So I'm quite happy to field any other questions that you might have.
Just now, no.
Yeah. You definitely need to go back on it. I'm going to.
Yeah, absolutely. Yeah.
I've done a lot of changing of this file, so I just want to undo all of that. Right, so if we move on then to our higher order functions, filter, map, and reduce. So if we take filter first. So what filter does is, filter is a method that we invoke on an array. And what filter will do, as its name kind of suggests, is it will return a subset of that array. And the subset that it returns depends on the anonymous function that you pass to filter. And what the anonymous function does is it needs to return a Boolean true or false. And if it returns a Boolean true, then the current element that's being processed is included in the output array. Otherwise, the element is not included. Filter creates a completely new array. It does not change the source array, or array of user profiles in this case. It creates a completely new array. So we would kind of say that filter is an example of a pure function. It doesn't change its source array at all. Back to the slides, let me just recall. So yeah, so filter takes a callback. Again, it only takes one argument, which is an anonymous function, and it selects entries from the source array, and based on some sort of criteria, it includes that element in the output array, not as I said. The selected entries are added to a completely new array, hence it's pure. And we have our example. So let's look at what it's doing. Again, I have my boilerplate at the start, and here we go. So profiles is my full array of profiles that have come back. I'm just sticking in some console.logs here and there so that you can explore it in the browser. So that's all that console.log is do. My objective is, what does it say, to find all the female profiles in the array of profiles. Now, of course, if we didn't have the filter higher order function, then we'd do something like this. Okay, we'd use a standard loop, iterate over the array, and put the entries that we were interested in into a completely new array, which is this one here. This is how, sorry, this one here, yeah. This is how you declare an empty array. But of course, we don't do that. And if you find yourself doing something like that, then you need to take a step back and say, well, is there a higher order array function that I can use to do what I'm trying to achieve. We write very, very few old style for loops in JavaScript, as it turns out. So here we go. Profiles is my full array. Here's my invocation of filter. Here's my anonymous function using the arrow style again. And again, I've got some console.logs, but you can, if you look at the return statement, I'm checking to see is the gender property of the current profile that's being processed, is it equal to female? Now I know that's what it's going to be because I looked at the nature of the data that's returned back. So if that entire expression evaluates true, then the current element that's being processed is going to be added into this completely new array here, and then I'm doing a console.log of it. And did I save that? I didn't, I think. So the console.log is that I producing all this stuff. So you can see there's a mixture of males and females there. And eventually, if you look at, I guess it's this one here, is it? It just contains the females. Yeah. So it looks as if it's working properly. Again, you can explore it yourself later on. I've got another example of filter as well. And what am I doing? I'm filtering out all males whose age is less than 40. Okay. And same again, it's an arrow function shorthand form of it because the arrow function, the anonymous function just consists of one line. So there's no curly brace. So again, like if you can interpret that, then you know that's good because you're following the whole arrow function syntax being used within the anonymous function context within a higher order function context. So there's a lot going on there in those 2 or 3 lines of code here. Any question about that one, I wonder?
No.
Oh, great. Map is the next one. Map is another higher order function. What map does is it takes your source array and it produces a new array from it. And there are as many elements in the new array as there are in the source array. But usually what the new array contains is extracts from the elements in the source array. So I think what I wanted to do is go through my array of user profiles, and I want to produce a new array that contains just a user's email and one other property as well, I think. So again, map doesn't change the source array, so it's what we would say is it's a pure function. Let's look at the example. Again, the code at the start is boilerplate as before. Here I have profiles, and the objective is create an array of profile email addresses. That's all I want, just the array of each person's email address. So there's going to be a 1-for-1. Again, here's the old way of doing it, which we don't do anymore. Here's my map. Again, takes a function as an argument, and I am constructing a new object, and I'm returning that. There doesn't happen to be any logic within this anonymous function, but there could be, but there isn't in this case. So there's only one statement, if you like. It's the return statement where I'm constructing my new object, and where I'm including their name and their email. So this is going to be an array that contains an array of objects where each object has a person's name and their email address. Just by the way, so there is only one statement in this anonymous function, so we could trim it down a little bit. We could get rid of that. Get rid of that. This is where you have to be careful now. Get rid of that. There is one thing that I didn't mention on the slides. I think I mentioned it later on. If you've got a shorthand form of the arrow function and it returns an object, you do have to enclose that object in parentheses. So it's another little gotcha from a syntax point of view. I do have to wrap that in parentheses. And I think that all works okay. The other thing too that you need to be careful about, you see the way there I had a colon. That can be problematic if you leave that colon there. There can't be a colon at a semicolon, sorry. There can't be a semicolon at the end of that single expression within your arrow function, the shorthand form of it. So I need to get rid of that and close my parentheses. Again, that's quite tricky to interpret, I think. The other example, is there another example? Profiles that map. The objective is create an array of profile ages. Yeah, it's kind of similar really. So I'm just getting the age. And again, no return statement, no curly braces, etc., etc. You can look at them later on yourself. That's map. Then the last one is slightly out of character in comparison to the two that we've looked at so far. And it's this higher order function called reduce. So reduce takes a callback and it takes a second argument as well. What the kind of high level objective of reduce is to compute some sort of accumulation over an array. Okay, to compute an accumulator of an array. So I've got an array I call reduce, and like the simple example might be I want to count the number of profiles of people whose age is less than 30. Okay, it's an accumulation. And what you've got to pass to the reducer is what is the initial value for your accumulator, which would be obviously 0 in the example that I mentioned there. And then you've got to pass it a callback, and in the callback, it will change the accumulator and pass it on to the next invocation of the callback. That's what needs to go on inside here. It needs to take the accumulator, the current accumulator value, process the current element, and update the accumulator based on the current array element that's being processed. Maybe sometimes it means it doesn't have to change the accumulator at all. Critically though, the anonymous function has to return the new value for the accumulator, whether it has changed or not. And why it needs to do that is because that return value is what is passed in to the next invocation of the arrow function as the array is being processed. You can see my anonymous function here is taking the usual things. It's taking the current array element that's being processed, its index position, and the entire array, should it need it. Again, these two are optional. This is not. But there is an argument at the very beginning, which map and filter didn't have. And that argument is a reference to the current accumulator value that has been calculated up to now. So the first time this anonymous function is called, this parameter here that's being passed into my anonymous function, it will be assigned the initial value for your accumulator. On all subsequent invocations of my anonymous function, this accumulator value will be whatever was returned by the previous invocation of the anonymous function. Bit of a mouthful. Just going to look at one example because I really think you need to look at these yourselves later on. Supposing I want to compute the average age of all of the profiles. So what I'm trying to do here, yeah, okay. Initially, I'm setting it to 0, and here I'm taking, here's my kind of my callback. I'm taking the current average, if you like. So, no, sorry. Okay, the objective is to compute the average. So what my reducer is going to do is it's going to compute a summation of all of the ages, and then I just compute the average down here by just dividing the number of profiles by the total age of all of the profiles. So all I'm doing in my reducer is, as you can see here, I'm taking the person's age, the current profile, taking that person's age and adding it to the accumulator that's being totted up. The initial accumulator is 0. I'm returning this expression, which means that the next time the anonymous function is called, total is going to have whatever was returned in the previous invocation. That's the simplest example of the reducer, where you're doing an obvious kind of accumulation, but the reducer has got other kind of useful use cases as well that you wouldn't necessarily think are appropriate for the reducer. And I have another example of that going on down here. I'm not going to talk my way through it because it's quite involved, but the overall objective of what I want to do down here is I essentially want to construct an object that looks like this. I want to compute how many people in my array are less than 25 in terms of their age, how many people are in this age bracket, how many people are in this age bracket, and how many people are in this age bracket. So that is my accumulator in this case, okay? And I can actually use the reducer higher order function to do that for me. And I'm giving you the code here, but I'm letting you look through this yourself because it's quite involved and I don't want to be talking my way through it line by line. It's quite complicated though, I think. Any questions?
Do you always set the initial value, or is that read?
Oh no, that's really important. If you don't give it an initial value, then, well, number one, you're going to get a syntax error, but number two, how does it know when the first time it calls the anonymous function for the first person in my array? It needs to know, well, what is the initial accumulator value? Because that's if it's not declared, then it's going to be undefined, or maybe something worse than that. So you're working with a value that doesn't make any sense. So like and it can be anything. It can be a primitive, which it is in the case of the computing the total ages. But if you look at the code, let's see. It could be an empty array. That might make sense in terms of an accumulator. It could be an empty object. I think in the case here, what it is this object here. That's my initial value for my accumulator. As in, I've nobody in any of the age brackets. That would make sense. My objective is to, as what I said it was there. So the initial value for the accumulator would be, they're all zeros. And then presumably within the anonymous function, it takes this object and it makes a change to one of these categories, depending on what category the person that's currently being processed is in. It increments one of those and it returns to the next invocation of the anonymous function. It returns this whole structure again, albeit it has been updated from what was passed into it. So
and just goes through each element of the array then, Yeah.
So the accumulator initial value, it's really important that you get that right, because if that isn't right, then the whole thing doesn't actually work, obviously enough, I suppose. But so it's not always as simple as just 0 if it's some sort of accumulation that you're doing.
Okay. Thank you.
Now, I'm just going to briefly. Arrow functions, I've kind of said that the whole point of arrow functions is to clean up the syntax of function declarations, be they function declarations, expressions, or anonymous functions, and that's true. That's one of the purposes that they serve. They do serve another purpose, which I'm loath to get into because, as it turns out, we don't actually need to know it, even though it is kind of an important part of the JavaScript language. You might be familiar from other languages like Java. There is what's called the this variable, and the this variable is always pointing at the current context, the current kind of runtime context. Now, in the case of JavaScript, it's pointing at some sort of lexical scope that your code is running in. And it was a real source of errors in the early days of JavaScript. Now, if I just very quickly explain what I mean by all of this. So I've got an object here, right, which I've called Jane. And Jane has some key value pairs. Turns out, right, that a key value pair in an object could actually be a function. That's perfectly acceptable. And we did a lot of that in the early days of JavaScript coding. So I've kind of been lying to you up to now by saying an object is a structure for representing complex data. An object can also contain behavior within it. And that was very natural in the early days of how we wrote our JavaScript code. So and we refer to, if a key value pair within an object is, if the value of a particular key is a function, then we refer to that property as being a method. And of course, that term is familiar to us from other programming languages. So it looks like Jane here has two data properties and also has some method properties. We don't have to order these in any way. We can mix and match them any way we want to. Sorry.
Quick question. If this JSON object has a function built into it, isn't it a security problem, especially if it's coming from an API?
No,
because you could send a function down to the browser from an API.
Yeah, so you would never do that, really. When you're talking about JSON as a way of representing data that's being transmitted across a network, then a JSON will always only have, or should always only have, data in it. But all I'm saying here is that just within the JavaScript language itself, a JavaScript object can have properties that are actually methods. I'm sorry, I'm making a distinction between JSON and a JavaScript object. You're right in what you said there. You should not and wouldn't really ever send a JSON object across a network where a property has behavior built into it. JSON is really meant to be for data representation, data transmission.
Okay, but it could happen. So it's actually a security problem.
For sure. For sure.
Okay.
Yep. So if we look at this method here, and the question is, within the method, if I want to refer to one of my data properties, how do I refer to them? And this is something that Brendan Eich, the creator of JavaScript, identified from the outset. And there is the solution. And the solution is you use the this special variable. So the expression this.name here is going to refer to this property here. That's the way it was designed in the language from day one, and everybody understood that. And that's fine. The problem, though, is, there's always a problem. If you look at this method here, I have, within the method, I have an anonymous function, which is this here. Forget about this for a second. Inside in an anonymous function, this variable is no longer referring to what we call the containing object. The containing object is the Jane object here. Up here it is, this is referring to the containing object. But when you have an anonymous function within a method, this variable is no longer referring to the containing object. It's referring to what's referred to as the global object. And the global object can be different depending on your runtime environments, wouldn't you know? It can be different from browser to browser, and it can be different between browser and node. And this was a major source of errors in the early days of JavaScript. the solution is that we say that we have to bind the this variable to the containing object. We have to express that some way within our code. And this is how you do it here. So the purpose of this little piece of code here is to bind or to point this variable at the containing object, my Jane object. And now this expression is going to be fine. And it's very, from a syntax point of view, it's very unusual, because if you follow the syntax, I'm invoking the bind method on my function. It's being invoked on a function. From a syntax point of view, that looks non-standard, but that is how you had to do it. But of course, you know, when you've got a large volume of code and you've got lots of anonymous functions around the place, if you forget to do this, then more than likely your program is going to crash, because this .name is no longer going to evaluate to what you expected it to evaluate to. And as we said earlier on at the very beginning of the lecture, in fact, this .name is going to refer to the undefined value. Okay, it's not going to cause any problem here because I'm just doing a console.log of it. But if I tag down something else onto this .name, then that's going to throw an exception and my program is going to crash. And what arrow functions did was they removed that issue in as much as it could. And so down here, again, I've got a method. I've got an anonymous function. My anonymous function this time, though, is coded with the arrow function style. And with the arrow function, this variable is automatically bound to the containing object for you, which 99% of the time is what you want it to be bound to. So you can see here, I don't have to use this bind dot stuff down here at all. This is now going to run fine for me. And that was the second main purpose of arrow functions. Now, in all of the code, and we will write a lot of code in this entire module, we never have to use this variable either at the browser end or, I'm pretty certain, at the node end either. And that's kind of a reflection really of what ES6 Plus has done. It has essentially tried to make this variable, global kind of variable, redundant, because it was a major source of errors in people's code. But having told you that, you know, as I said, we don't ever use it. I'm pretty certain. How do you know now it's going to arise at some stage down the line? But it's certainly not in anywhere in my code. But that was the other main purpose of these arrow functions. It wasn't just a syntax cleaning up kind of operation. It was to resolve the problem with using anonymous functions in your code and the correct binding of this variable. Right, that's all I want to cover in terms of the language. And surprise, surprise, I haven't gotten into the React stuff at all. What should I do? Do this actually. Now, I know one or two of you were asking me about kind of assignments and that kind of stuff. I'm not going to get into assignment. I might actually put together a specification for the first assignment next week, even though it's far too early because it's going to be all based on React and we haven't started React yet. But in the labs, not from next week, but from the following week, for 3 to 4 weeks, we are going to be rolling out an application week on week. And I'm just going to give you a quick demo of the application so that you can see roughly kind of what we're trying to achieve or hope to achieve. And I can publish this link. So I've just I've deployed the application up on a cloud platform for myself, so I can publish this URL later on. So so this is a React app that is using a web API called the TMDB API. TMDB stands for the movie database. So the TMDB API has loads of information about movies, and it's right up to date, really. And we're writing a client against that. And so this is the home page of my React app. And when I loaded this page into the browser, it sent an API request to the TMDB API, and that sent back an array of 20 entries, each containing information about a movie, including references to images, etc., etc. So here's the 20 movies that it returned back to me, and I'm rendering some of that data. And the kind of things I want to be able to do to a movie is maybe select a movie as being a favorite of mine. So I'm going to click on this little icon here, and it's tagged as being a favorite, and I'll click this as being a favorite. I have a separate page then that shows me all my favorites, which is over here. Okay, I can remove that favorite if I want to. Going back to my home page, I can click on a link here called More Info. When I click on that, it sends another request to the TMDB API, and that sends me back more detailed information on the movie. And I display a new page, and here's some more facts and details about this particular movie, an overview of it, the various genres it belongs to, etc., etc. Movies also have reviews that are stored on the TMDB side. So movies don't have reviews. I don't know if this one has or not. Turns out it hasn't. So I get one that does. I know this one does. So this is all React code now that's running in the browser, and the React code is generating what you see. None of what you see here is being generated from the server side. All that I'm getting from the server side is the actual data. So if I click on reviews, here are some actual reviews that have been written against this movie. Again, I had to make a request to the TMDB API to get this information, and I'm just displaying an extract from the review. This is how I decided to do it. I'm displaying an extract from the review, but you have the option of seeing the full review. So if you click on this link here, then I think it sends another request back to the API to get the full text of the review. And so I get the full text of my review. And there's another, there's an upcoming movies. Sorry, now there are things popping up in front of me. There's an upcoming movies link here, which it looks like it's showing me the same list of movies as the home page, but if you look at it in detail, it's slightly different, and this is meant to show me movies that are upcoming in theaters around the country, but there is some overlap. But it is a different set of movies. Again, same kind of structure there. On the favorites side as well, what I am going to build in eventually, sorry now because there are things just popping up in front of me that I'm trying to close off. I want to be able to write my own review about a movie, and eventually this button here will bring me on to a new page, and eventually there'll be a web form here where I can enter my name, contact details, and my actual review, and I can save that. Although it won't save it back to TMDB, it's only going to save it locally. But you get a sense of what we will roll out in the labs over, as I say, about a 3 or 4 week period. And then you can either take the end result, which is effectively what I've demonstrated here. With this exception, I'll add this onto it as well. Take that and flesh it out further, because the TMDB API has lots of other endpoints, as we call them. All I've accessed is the movies endpoint, but it also has loads of information on various actors and actresses. It has information on TV series and lots of other endpoints as well. So there's an endless source of data there available to you that you can pull and display in whatever way you want to, and add features onto this React app, whatever way you want to actually take it. Or you can start from scratch and develop a React app for a completely different API. Of course, the advantage of this, of taking the movies one, is that you have a solid code base on which to build, but you may be interested in something else, and that's fine. And we'll kind of take that into consideration when we're assessing it. just as I've demonstrated, is there any questions about? I mean, I've just kind of skimmed over it really obviously, but do you have any questions about the demo? No. Okay. I was kind of conscious of the fact that obviously I wanted to get into, sorry, let me go back to the website. We all want to get into the React stuff, but I just wanted to make sure that I covered JavaScript so that everybody started a solid foundation. So unfortunately, I'm not going to get into this stuff now until next week. So our React stuff starts on this is week 3, week 4. It's quite late, but we will start into it. There's no point in starting it now, really. We'll start into it next week, and for the next, I really will need 4 weeks, so that'll bring me into week 7. I'll need 4 weeks to get through all of the React stuff, and we'll be ripping through it, admittedly. So unless people have any questions, I suppose we nearly need to call a halt to it, I suppose, to the lecture. Any final questions before I wrap up?
No, thanks, Dermot. No.
I just saw that storybook in the title there. What is Storybook?
So Storybook is a tool for developing components in isolation. React is all about developing components. That component is kind of the unit of composition. You could think of it as like a class, maybe in normal programming terms. But and a component generates some part of the UI. If I go back to actually, let me share the screen again. Did I close it off? Maybe I did. So I've got a component that generates this card here, as we call it. I've got a component that generates this card over here. I've got a component that generates the list of cards, and so on and so forth. I've got a component that, you know, generates maybe this set of what are they called? Are they called pills? There's some name for them that generates these. So a component is a piece of code that generates part of your overall UI. And what Storybook allows you to do is to ensure that the component is working in isolation rather than having to see it work within an entire application. So you can get Storybook to display just this component's output for you. And the idea is that you would write your components, get Storybook to render them for you. Then when you're happy that it's rendering properly, and you may be tweaking the functionality of the component or tweaking the styling of it, then you start stitching your components together into your overall app. That's meant to be the way it works, but to be truthful, I suppose what you would probably do is you would just go straight into writing components and adding them onto an overall page. But Storybook is nice in that it allows you to build up a catalog. In real life and in industry, companies that use React would have catalogs of components, obviously with the intention of reusing components from one project to another. And Storybook allows your developers to look through the catalog and see what each component displays and whether they can use that component or not, rather than trying to extract the component from within a larger application and seeing what it displays by looking at the overall application's page or pages. Yeah, that's the idea.
So Dermot, does that mean that there are components in existence already, sort of, you know, something like Bootstrap that you could pull into?
For sure, there are thousands of third party, as we would call them, components out there. We will be using a third-party library called Material UI that will help. That's a library of third-party components specifically to simplify the styling side of your React app. When we're styling, we're obviously talking about CSS. Now, we could write all of our own CSS, but there are third-party CSS component libraries out there which will do some of that work for us. And one of them is called Material UI, and we'll be using that. But there are other third-party components libraries that have useful things. So, for example, you might use a third-party component that implements a date picker rather than you implementing your own date picker. So yeah, there are loads of them out there, and you can go looking around for interesting component libraries. I'll build that into the spec, but I guess the real objective is to get you to write your own components so that you become very familiar with React from the ground up.
Okay, thank you.
Okay, so we'll leave it at that. That kind of means that in terms of the lab this week, the only thing you can really work on is the second lab from the first session. That's the functions lab. I anticipated that. I didn't. I was hoping to get started with React, but I wasn't expecting to get very far in it. So I'm only slightly behind from my point of view anyway, in terms of the progress that we're going to make. But so be it. Right, folks, I won't hold you any longer. So thanks for turning up, and I will be in touch with you on Thursday and talk to you on Tuesday again next. Okay, bye for now.